In this video, we introduce Point2Graph, an end-to-end point cloud-based open vocabulary 3D scene graph for robot navigation. 3D scene graphs provide a structured scene representation by organizing rooms, objects, and their relationships in a spatial hierarchy. One of the main challenges for both closed and open vocabulary 3D scene graph generation is the scarcity of large-scale 3D text datasets, especially compared to the abundance of large internet-scale 2D text datasets. Most of the current literature in generating open vocabulary 3D scene graphs such relies on well-aligned RGBD images and 3D point clouds to perform feature distillation or projecting features of RGBD images to 3D point cloud to create 3D text pairs. However, these algorithms have a requirement that well-aligned posed RGBD images are available, which is usually challenging to achieve in real-life scenarios. To eliminate the hard-achieving requirement of the current open vocabulary 3D scene graph generation, we propose Point2Graph. This framework only utilizes 3D point clouds as input to generate an open vocabulary 3D scene graph. Generally speaking, our framework consists of a room segmentation and classification module and an object detection and classification module. At the room level, we enhance segmentation performance by combining a geometry-based border detection algorithm with transformer-based region detection and forming a snap lookup framework for open vocabulary room classification. In segmentation part, we first apply a geometry-based method to generate a border-enhanced density map, and then pass the segmented result into a transformer-based region detector to get the segmented room region. After getting the segmented result, we apply a snap lookup module to classify different rooms. In snap module, cameras are positioned evenly at the ellipse-shaped trajectory facing to the center of the room and snapshot the room from different positions. In the lookup module, we associate each room with open vocabulary embeddings extracted from K-representative CLIP features. Then, argmax and majority voting are applied to get the type for each room. In object level, we separate it into two stages. In the first stage, we do object detection and localization using class-agnostic bounding boxes and DB scan filtering for object refinement. And then we do object classification via cross-modal retrieval, connecting 3D point cloud data with textual descriptions without requiring annotations or RGBD alignment. Then the two layers are merged to get the final 3D scene graph. Then it can be used in room and object query and robot navigation. Here is the qualitative result of Point2Graph. We both evaluate the result of the Matterport 3D dataset and the real-world scene. Here is the room-level evaluation result. From the result, our algorithm both outperforms the state-of-the-art algorithms in segmentation and classification. Here is the evaluation result of object-level evaluation. Our result also outperformed the current state-of-the-art algorithm. We construct the 3D open vocabulary scene graph using Point2Graph algorithm and construct the Voronoi navigation graph. Then we conduct navigation tests in this environment.